introduction to another method, homogeneous of degree, we need to understand what it means to be homogeneous of degree N. And again, I will be calling this homogeneous of degree because another definition in our class is a differential equation that's homogeneous, and that means something totally different in this context. So homogeneous of degree N is if I replace with a function x and y, I replace the x with a lambda x, and I replace the y with a lambda y. And I can factor out a lambda to the nth power times the function itself, xy. So that's what we mean by homogeneous of degree N. So I have three examples here. Here's my first function, square root of x plus y times quantity 4x plus 3y. So the first thing I'm going to do is I'm going to replace the x with the lambda x and the y with the lambda y. So wherever there's an x, I put lambda x. Wherever there's a y, I put lambda y. So lambda x plus lambda y, and then 4 lambda x plus 3 lambda y. So now that I have that done, now that I have x replaced with lambda x and y replaced with lambda y, now let's see, can I get this original function that I started with a lambda to a power on the outside? Well, I noticed that I can factor out a lambda to the 1/2 out of the square root. That's first. I can take that out. Then in the second part, I notice that I can factor out a lambda out of it also, and I'm left with 4x plus 3y. So what do I notice then? I notice that if I put these lambdas together, I have lambda to the 3/2 times the square root of x plus y times 4x plus 3y. So what do I notice? Well, this is lambda to the 3/2 times f of xy, because this is the original function, what I have underlined. So this is homogeneous of degree 3/2 because of that 3/2 right there. So now, here's my next example, f of xy equal to sine of x over x plus y. Step 1, wherever there's an x, put lambda x. Wherever there's a y, put lambda y. So replace that within the sine function, lambda x over lambda x plus lambda y. Now, again, I want to see, can I get sine of x over x plus y back? Well, what do I notice? I can put the lambda here, x. I can factor out a lambda here out of the x plus y. Well, those lambdas cancel each other out. Lambda over lambda is 1 because lambda is not 0 here. So I end up with sine of x over x plus y. Well, that's the original function. So somebody might say, well, this isn't homogeneous of degree because I ended up with the original function. There's no lambda outside. But think about it. Really, this is lambda to the 0. So this is of degree 0. It's homogeneous of degree 0 in this case. My last example, f of xy equal to x plus y plus 1 quantity squared. First step, replace the x with the lambda x, replace the y with the lambda y. So everywhere I see an x, put lambda x. Wherever I see a y, put lambda y. Now again, I want to try and factor out a lambda, a power of lambda, and have the original function x plus y plus 1 squared. But the problem is this one. I can't factor a lambda out of it. I can't factor a lambda out of this whole thing and lambda to some power and have x plus y plus 1 quantity squared. Why can I not do that? Because there is no lambda in the 1. So this is not homogeneous of degree n. The idea is, again, is that the powers are the same wherever, whatever term, the powers are the same for that function. And that's what we mean by homogeneous of degree n.